Good day everyone! So for today, we are going to solve some problem in chapter 3, the total hydrostatic force on surfaces. So our problem is, a 10-meter diameter spherical red balloon is tied to the park bench by a rope and is filled with helium gas pressurized to 106 kilopascal at 27 degrees Celsius. Calculate A, the specific weight of the helium gas, B, the volume of the balloon, and C, the tension in the rope while disregarding the balloon's dead weight. Use universal gas constant 212 meter per degree Kelvin for the helium gas, and specific weight of air is equal to 11.76 Newton per cubic meter. So this is the figure for our problem. This is the balloon and this is the bench or the park bench. And the given are pressure of 106 kilopascal, temperature of 27 degrees Celsius, and our universal gas constant of 212 Newton per cubic meter, and the specific weight of air, which is 11.76 Newton per cubic meter. So we have to find the tension of the rope, the specific weight of the helium gas, and the volume of our balloon. So first, let us solve for our specific weight of the helium gas. So we will use the formula P over RT. Our pressure is 106 kilopascal, so 106 times 10 raised to 3 or 10 cube. Then our universal gas constant, we have 212 meter per degree Kelvin and 27 degrees Celsius. So we have to add 273.15 plus 27. We get 300.15 degree Kelvin. Then we have to cancel this degree Kelvin and we get this answer, 1.666 Newton per cubic meter. Next, we have to find or to solve the volume of our balloon. So we will use the formula for volume of sphere, which is 4/3 pi r cubed. So the volume of balloon is equals to 4/3 pi. Then we are given with diameter, so we have to divide it by 2. So 10 meter over 2 cube. So plugging it in our calculator, we get the answer for the volume of the balloon, which is 523.6 cubic meter. Then let us proceed to letter C, or the tension in the rope while disregarding the balloon's dead weight. So we will use the formula buoyant force minus the weight minus the tension is equal to 0. So first, we have to find for our buoyant force. So the formula for our buoyant force is specific weight of air times the volume of the balloon. So plug in the values. The specific weight of air, we have 11.76 Newton per cubic meter. And the volume of our balloon is 523.6 cubic meter. So plug in this again in our calculator. Buoyant force is equal to 2,982.3 Newton. Then now, let us solve for our weight. So weight is equal to specific weight of our helium gas times the volume of our balloon. Plug in again the values. We have specific weight of helium, which is 1.666 Newton per cubic meter, times the volume of the balloon, which is 523.6 cubic meter. So we get the answer of 872.3 Newton. So plug in this buoyant force and the weight. We can solve now for our tension. So the buoyant force, we have 2,982.3 Newton minus our weight, which is 872.3 Newton, is equal to our tension. So the answer for our tension is 2,110 Newton. So our answer for letter A, which is the specific weight of our helium gas, is 1.666 Newton per cubic meter. And the answer for letter B, the volume of the balloon, is 523.6 cubic meter. And then for letter C, the answer is 2,110 Newton.